Welcome to homework.
In problem 78, we have a 5,250 pound force acting at point C. And we know all the information except for the angle between AC and CO. So drawing a triangle, we can find that. Between points A, C, and the origin. Looking for this angle, which I'll call alpha. We know that this distance is 56 feet. And we're also given the length of AC as 70 feet in the problem. So taking the tangent of alpha, we set equal to the opposite side over the adjacent side, and solve for alpha, which we get to be 53.1 degrees. Now we can solve part A of the problem, which is finding the x, y, and z components of the resultant force acting at point C. So in the x direction, the resultant force is negative. And we can multiply it by the cosine of the angle alpha we just found to transfer over to the xz plane. And then we have to multiply it again by the sine of 50 degrees to get the x component of the force. Solving, we get that in the x direction, the force is negative 2,415 pounds. Finding the force in the y direction is a little bit simpler. We have our 5,250 pound resultant force, and we simply multiply it by the sine of the angle 53.1 degrees, which will give us the opposite side of the triangle, or the y direction. It comes out to 4,198 pounds. And lastly, we can solve for the force in the z direction, which is also in the negative z direction. We multiply by the cosine of 53.1 degrees to get into the xz plane, where we can then multiply it by the cosine of the angle 50 degrees, which will give us the z component. It comes out to negative 2,026 pounds. Part B of the problem asks to find the angle in the x, y, and z direction that the force is acting. We can use this formula where the cosine of the angle of the resultant force in each direction is equal to its force in that direction divided by the resultant force. And we just solved for each component of the force, so I can plug in f of x as well as the resultant force we were given. And now we can solve for theta in the x direction and get 117 degrees. We can use the same formula for the y and z direction as well. Plugging in the value we found over the resultant force, we get that theta in the y direction is equal to 36.9 degrees. And lastly, we have the angle in the z direction. Now it's important to carry over the negative sign, or you will get the wrong angle. And finding our last angle in the z direction, we get that it's 113 degrees.